Hello everyone and welcome back to the channel. This video is a part of a PYQ series for Intermediate Microeconomics 2. In this series, we will go through important previous year questions, exam patterns and key concepts to help you prepare better. So let's get started. This is for the year 2025. This is first question from the chapter Monopoly. A private railway company is being given which is running a train between Jaipur and Udaipur which has a capacity of 200 passengers. The fixed operating cost per trip is being given to us as 3600 rupees. The demand function being given. The first part asks, if the railway company charges a single uniform fare, how will it decide whether to operate the train and what will be its decision? So for this we have to find out the profit, whether they are incurring any profits by operating the train or not. So given that the P function is 60 minus Q upon 4, this has been given to us, the capacity 200 passengers and the fixed cost 3600. So from our demand function, we will first find out the total revenue function, which is P into Q. 60 minus Q upon 4 into Q, which is 60Q minus Q square by 4. So this is the total revenue function that we have derived. Next is finding the marginal revenue function by differentiating the total revenue function with respect to the output. So if we differentiate the total revenue function, it would be 60 minus Q by 2. Now, since the cost per trip is fixed, that means cost being given to us per trip is fixed. So therefore the marginal cost is equal to 0. Now the profit maximizing condition is MR equal to MC. Always in your paper do mention the conditions and then numerically solve it. MR is equal to MC. This we know is the profit maximizing condition for a monopolist. So marginal revenue is being 60 minus Q by 2, putting it equal to marginal cost, which is 0. The value for Q comes out to be 120. Now the total number of the passengers, the capacity is 200 and we are getting 120 passengers, so that means this is the right answer. From Q, putting it back into the demand function, we will get the prices 60 minus 120 by 4, so prices would come out to be 30. Now computing the total revenue and from P into Q, that would be 30 into 120. So this would be 3600. Now finding the profit function, which is TR minus TC. Total revenue is 3600. The total cost function is also 36. So that means 0, equal to 0. Now as you can see, the profit comes out to be equal to 0. Then hence the monopolist is indifferent between the train services. So the train services might just operate, but when it comes to earning any economic profit, that would be 0. So the final answer would be that the no economic profit that is there. But the train services may just operate. Then the next part of the question, find the socially efficient ticket prices. Is it socially desirable to run the train? Let's have a look at this one. So now efficiency. We have to find out the socially efficient ticket prices. The efficiency condition is P is equal to MC. So putting it, price is equal to marginal cost we know as MC is equal to 0, that we have computed. So that means P is also equal to 0. Now if at P equal to 0, putting it back into the demand function, we will get our value of Q as 240. But if you recall in the question, the capacity binds, or the maximum number of passengers that the train has, the capacity is given to us as 200 only. So as Q is equal to 200, which is binding, so computing the price at 200, that would come out to be efficient prices 60 minus Q upon 4, which is 10. So at Q equal to 200, the prices that will be set is nothing but 10. So now finding the total revenue and total cost from here. Total revenue is P into Q, that would be 10 into 200, which is 2000, and the total cost is 3600. So the profit is TR minus TC, which would be 2000 minus 3600. Now this is minus 1600, which is coming out. So minus 1600 means, as it is coming out to be negative term, that means the firm is incurring losses, as the total cost is more than the total revenue which has been generated. So the firm would not operate at rupees 10. It would obviously need a government subsidy to break even. So find the socially efficient ticket prices, that is P is equal to 10. Is it socially desirable to run the train? Now if we compare the total social surplus with the cost of running the service, we will get to know whether it is socially beneficial to provide the services or not. We can also understand it through a diagram. First, by taking prices and quantity. Now at demand function 60 minus Q by 4, if this is our demand function, the intercept at Q equal to 0, the maximum prices is 60, and this would be 240. The price set at the capacity level of 200, let's say this is 200, this is nothing but 10. So marginal cost is given to us as 0, so this is marginal cost equal to 0, and this area is nothing but the losses that has been incurred. we know the losses is minus 1600 that has been there. So now finding the, you can either first find out the consumer surplus, or we can find out the total welfare that has been there, total social welfare that is there. Now consumer surplus is half base into height, that is 60 minus 10, that basically the area under the demand curve and above the price line. So 60 minus 10 into 200, this would come out to be 5000. So consumer surplus is 5000. So now consumer surplus at P equal to 10 and Q equal to 200 is 5000. The producer surplus is minus 1600. So that means the total social surplus is consumer surplus 5000 total social benefit or total social surplus that is there (5000 minus 1600), which is 3400. Now this is greater than 0, so basically the total surplus, as a society, the gains are there from running this service. So a clear net social gain which has been there. So the monopolist, from the aspect of socially desirable to run the train, yes, but at the same time the government should subsidize, the subsidy cost would be given, so the monopolist will not voluntarily provide efficient level without any subsidy. That is there. Let's have a look at the next part now. Now the next part talks about, if the monopolist firm was able to effectively, perfectly price discriminate, would it provide the service? Will it be at the efficient level? Show your workings and explain. We know from our knowledge of perfectly priced discrimination that the monopolist captures the entire surplus. So the firm, in this case, is going to charge each of their 200 passengers exactly their willingness to pay. That means from 60 rupees down to rupees 10. So now we have to calculate the total revenue or area under the demand curve from Q equal to 0 to Q equal to 200. So the firm charges, this means that the firm charges each of 200 passengers their maximum willingness to pay. And why? Because in perfectly priced discrimination, we know that the entire consumer surplus is captured. Exactly 200 passengers, their maximum willingness to pay. So that means the total revenue when Q is equal to 200, now if we come back to the diagram that we make, this was the diagram that was there. Now if you look up at the diagram at Q equal to 200, or we can extend it like this to understand. So either you can calculate the total area that has been there, or the consumer surplus comes out to be 5,000. So consumer surplus 5,000 with this one, and the area of this would be 200 into 10, which is 2,000. So 2,000 of this and 5,000 of this, so total comes out to be 7,000. So that means, or by directly using the formula also you can find it out. Total revenue when Q is equal to 700 is, when Q is equal to 200, that means half 60 plus 10 into 200. So the total revenue would be 7,000, and the total cost we know is 3,600. So from there computing the profit, which is TR minus TC, 7,000 minus 3,600, which comes out to be 3,400. So the profit is rupees 3,400, where the entire consumer surplus is being extracted. So that means consumer surplus is 0 in such a scenario. So now with the perfectly priced discrimination, the firm is earning 3,400 rupees profit. So they would like to operate willingly. There would be no subsidy that would be needed. All the surplus is just converted into a producer profit. So the firm collects the entire area under the demand curve, both the regions combined as shown in the figure, turning the loss into a 3,400 rupees profit. So that was the first important question of year 2025. Let's have a look at the second question now. This is from the chapter Exchange Economy. Now consider a pure exchange economy, two consumers being given A and B, two goods X and Y. The consumers have the following utility functions: for consumer A, XA plus YA; for consumer B, XB plus 2YB. Initial endowments given 0, 1 and 2, 0. And in the first part we have to draw the Edgeworth box and identify the initial endowment. The second part, indifference curves of consumer A and consumer B passing through the initial endowment point. And in the third part, find the set of Pareto optimal allocations and explain your result. Okay, so this is the given part that has been given to us. Now, if you look up at the utility functions, XA plus YA, that means this utility function represents a perfect substitute case with MRS equal to 1. Between two goods, the marginal rate of substitution is 1. The second, the utility for B, XB plus 2YB, is also perfect substitute utility function, where the MRS would be 1 by 2. Now, the total endowment being given to us is 2 comma 1. How? The total good of x, which is nothing but 0 plus 2, as you can see, for a individual it is 0 comma 1, and for b individual it is 2 comma 0. So the total good of x that is available in the economy is 2 units, and the total good available for y is 1, which is 1 plus 0 from here. So that will represent, now we will draw Edgeworth box. The origin for consumer A, the origin for consumer B, total X good, total Y good for consumer A, for consumer B, X good, which is representing the width, and the height, the Y good. This is an Edgeworth box. The total units of good x is 2, that means this is nothing but 0 till 2 units, and this total unit of good y is 1. So this is going to be 1. So this is our Edgeworth box with the initial endowment. Initial endowments, as you can see, 0 comma 1 and 2 comma 0. So that means this would come out to be xa comma ya 0 comma 1. That means for a, this is the point at the corner. That means a has all of good y and none of x, and similarly for b it is 2 comma 0. That means b has all of x and none of y. Okay, so the first part talks about draw Edgeworth box for this economy and identify the initial endowment point W, which is there. This was the first part. Now for the second part, draw the indifference curves of consumer A and consumer B through the initial endowment point. Now let's identify the indifference curves through the endowment W. For A, let's write the utility function first. For A, the utility function is xa plus ya is equal to 1. The IC through indifference curve through 0 comma 1 is ya is equal to 1 minus xa. That means indifference curve, as is it is a perfect substitute case, that means indifference curve is a straight line which is starting at the endowment W and cutting diagonally all the way to the bottom right corner of the box. So IC is a straight line connecting 0 comma 1 and 1 comma 0. Now the next is for B individual. So the curve is a straight line which starts at This was our Edgeworth box, 0A, 0B, X good, this is Y good, X good, this is Y good. So this would be our indifference curve for consumer A, which has a slope of -1. Let's have a look at the indifference curve for individual B, which is UB is equal to XB plus 2YB. Putting in the values, XB is 2, has all the good X and no good Y. That means the utility for B is 0. So indifference curve of consumer B is, for consumer B, is also a flatter straight line which starts at the endowment W and cutting diagonally all the way to the bottom right corner with the slope of -1/2. And over there, the initial endowment point is 2, 0. Consumer B's indifference curve with a slope of -1/2. So through the initial endowment, draw the indifference curves of consumer A and consumer B. Next is, this is the solution for second part. Now the next is find the set of Pareto optimal allocations and explain your result. Let's have a look at finding the Pareto optimality. Now for Pareto efficiency in exchange, we know that the MRS must be equal. So for A, MRS is given by mu x by mu y, which is 1/1, which is 1, and for B, MRS for B is mu x by mu y, which is 1/2. So clearly we can see that as MRS for individual A is greater than MRS for individual B, that is 1 is greater than 1/2, which is 0.5. So ICs are linear and they can never be tangent to each other. So what we can infer from this Pareto improvement regions, that the area between the both the IC, the wedge moving toward the right side of the box, that is what the Pareto improvement region is going to be, where the allocations, both the consumers gain higher utility than their initial endowment. So that means let's have a look. So the set of Pareto optimal allocations is the contract curve on the boundary of the box where no further mutual gains are possible. So the efficient set consists of allocations जहाँ पे goods are fully specialized, that is one agent gets all of one good or the other depending on the feasibility and the utility gains. So Pareto set is the set of allocations satisfying the conditions YA is equal to 0 for XA belonging to from either from 0 to 2, or XA is equal to 2 for YA belonging to 0 to 1. That means B has all of good Y and A has all of good X. Now that means as A is valuing, as consumer A values X good more than B, he can only be made better off without hurting B. That means by trading Y for X. So now what will be the final outcome? The A, to get the contract curve, A will have to give all of good X, that is XC equal to 2, and no good Y in the Pareto improvement condition, and B will have all of the good Y and none of good X. That will be there. So the contract curve, as we can see, would be OA, OB. So this is the contract curve segment. This is the contract curve segment. XA equal to 2 and YA belongs to 0 to 1. This is also contract curve. YA equal to 0, XA belonging to 0 to 2. So consumer B has all good Y and consumer A has all good X. So as A values X good more than B, he can be made better off without hurting B. So that how that is possible? By trading Y for X. So that means, so A will have all X good and no good Y, and B will have all Y good and no good X. So this is the solution for this part. Now for more important questions, we'll come back in the next video. Thank you.